Okay. Thank you, Sanya, for telling me. Just wait for a second. Now I am audible, Sanya. Am I audible now? Okay, okay. Thank you, Sanya. Okay. So I said in the till the last class we have understood how atoms, where Dalton said that atoms are indivisible. But as per the modern atomic theory, we know that atoms can be subdivided into three subatomic particles: electron, proton, and neutron. Now I'm audible? Okay, thank you. Thank you, Sanya, for reminding me. Okay, so now in the till the last class, we have understood how discovery of electron helped to find out that atoms are not indivisible. Atom can be subdivided into electron, proton, and neutron. Right? So let's see what is an atom. Right? We know that atom is the smallest unit of element, consists of a central nucleus surrounded by one and more electron, right? And what is the nucleus, right? So we know that this is a nucleus. This is the central part of the atom and composed of protons and neutrons. Composed of protons and neutrons, right? That contain most of the mass, contains most of an atom mass. It means if I say, if suppose sodium is having 23 mass, so who is contributing the atomic mass? The nucleus, because nucleus contain two subatomic particles, protons and neutrons. You can see the positively charged yellow colors particles are proton, and then orange color these particles are what? Neutron, and you can't see any charge on them. They don't have any charges, right? Understood? Then what is a proton? What is a proton, right? So proton is a positively charged particles found within an atomic nucleus, right? It never participate in the chemical combination. You will never see that protons are participating in the chemical combination. Only electrons are jumping. Only electrons are jumping from one element to another, right? So what is a proton? Proton is a positively charged particle which is present inside the nucleus. Just now we have seen, and found within an atomic nucleus, right? Only electrons are participating in the chemical combination and protons are not participating. And we have seen in the till the last class that electrons are having negative charge and protons are having positive charge, right? So what is a neutron? Just now we have seen in the nucleus there were two subatomic particles. One is proton and another is neutron. So what is a neutron, right? So neutron is uncharged particle. You can't see any kind of charge on neutron, and then it is found within an atomic nucleus. We have seen what is the position of neutron. The position of neutron is within an atomic nucleus, and neutron also contribute in the atomic mass of an element, right? It means who is contributing, who is contributing the mass? Obviously neutron and proton both are contributing in the mass of an atom, because protons are having 1u, right? What is the mass of one proton? 1u. And what is the mass of neutron? That is also 1u. It means both are equally responsible for giving mass. So the mass is located in the center, in the nucleus. Just now we have seen, and who all are responsible? Protons and neutrons, right? And what is an electron? In the last class we have seen electron is what? Electron is a negatively charged particle located in shells that surround an atom's nucleus, right? That surround an atomic nucleus. And you must have seen only electrons are jumping from one element to another for chemical bonding, but proton and neutron, they always remain inside the nucleus, right? So now we can see now. I will show you, just wait for a second. Now we have understood about the discovery of electron. We have understood about the discovery of electron. Now I will show you the discovery of proton. So today we are going to discuss how how protons were discovered and who is responsible for discovery of proton. Can anybody tell me who has discovered proton? Who has discovered proton? Can anybody tell me who has discovered proton? You know that protons were discovered by Goldstein because existence of positively charged particle in an atom was first shown by Goldstein in 1886. In 1886, he took a discharge tube with a perforated cathode, right? With a perforated cathode. Now I will show you that what was arrangement he has done. This was the arrangement done by Goldstein, and Goldstein is responsible to show the existence of positively charged particle. Just now we have seen. No, not Priyansh. Rutherford has discovered nucleus. Just now you have seen the nucleus. Rutherford is responsible for the discovery of nucleus. Goldstein is responsible for the discovery of proton. Just now we are studying. And in the last class we have done the discovery of electron by J.J. Thomson, right? So now we are going to study the production of production of anode rays, and you know that anode rays are also known as canal rays, right? Anode rays are also known as canal rays, and this was shown by what? Goldstein, right? What he did in this, now you know the what is the meaning of discharge tube. We know that discharge tube is what? It is made up of hard glass and always has two metallic plate. One is electrode, another is both are electrode. One is positive electrode, another is negative electrode, and it is always attached to a battery source, I mean a very high voltage battery. That is you can say the induction coil, and which has a capacity of 10,000 volt, right? And it is this looking like a similar experiment which was conducted by J.J. Thomson, but in this case you will see that cathode electrode is perforated. What the Goldstein done? He has taken perforated means porous. There were holes in the cathodes, right? There were holes in the cathode, but it was not there in case of J.J. Thomson. When J.J. Thomson has discovered electrons, he has not taken a perforated one. But who has taken perforated cathode? So perforated, that's why the name of this anode rays are also known as canal rays, because these rays are going to pass through these pores, canals, right? And that's why a canal rays name came, right? So what Goldstein has taken, he has also taken the discharge tube. We know the discharge tube is made up of hard glass, which always have a two metallic plate attached here. You can see one is anode, that is attached to the positive terminal of the battery. You can see it is attached to this is the positive terminal of the battery. Then this is induction coil, you can see here. Okay, so it is attached to the positive terminal of the battery. Anode is always known as positive electrode. Why? Because it is always attached to the positive terminal of the battery. Cathode is always attached to the negative terminal. You can see this is the negative terminal and this is negative electrode. And negative electrode in this case you can see is a perforated one. Why perforated one? Because pores are there. Understood? So now what he has done, I have told you, he has taken a perforated cathode, but it was not done in case of J.J. Thomson. He has taken a normal one, right? Now he took a discharge tube with a perforated cathode, as you can see in this figure I am showing you right now. So he took a discharge tube with a perforated cathode, and he took a gas inside this. You can see there is a vacuum pump also. Why we have used this? One side tube is there to adjust the pressure inside the discharge tube, right? So that we should increase or decrease the pressure inside the discharge tube. Understood? So we can see that when he has he took a discharge tube with a perforated cathode and a gas at a very low pressure taken inside the discharge tube, and on applying high voltage, I told you what is the capacity of this induction coil, 10,000 volt. You can see it was 10,000 volt. Just wait for a second, let me reduce the size of the pen. Now you can see I told you what was the capacity of the voltage. The capacity of the voltage was 10,000 volt. Okay, so I told you what is it, because these are the key points you should remember. 1, 2, 3, 4. You can see that this cathode is what? Perforated one. Because during the discovery of anode rays, we should always remember that the cathode should be, if you need to draw a diagram, you should always remember that we have to make a perforated cathode, not a simple cathode, right? And then what was the source of the battery? How much voltage? 10,000 volt. And why this vacuum pump is there? In order to adjust the pressure inside the discharge tube, right? So on applying high voltage, as I told you, 10,000 volt, about 10,000 volt between the anode and cathode. This is anode and cathode. So how much voltage was applied between anode and cathode? 10,000 volt, right? It is observed that just as a fluorescence was observed on the glass wall of the test tube, this not discharge tube, right? And due to the what? Cathode rays. Now you can see this side fluorescence can be seen, right? It means when he has applied 10,000 volt voltage, means then it is very high voltage, and the gas was taken at a very low pressure, and he took the perforated, and after applying, what was the observation? He saw a fluorescence. Which side? At the back of the cathode, where he could observe the fluorescence at the back of the cathode, right? And it was observed at the back of the cathode, and this shows that some rays are coming from the side of the anode. This shows that some rays are coming from the side of the anode, and which pass through these holes. You can see these holes, and they're passing through these holes, right? We can see these rays are passing through these holes. What was the initial point we should remember? We know that the existence of the positively charged particle in an atom was shown by the Goldstein in 1886. He took a discharge tube with a perforated cathode, and he took a gas at a very low pressure inside the discharge tube, and on applying high voltage, that is 10,000 volt, between anode and cathode, he observed the fluorescence. Which side? At the back of the perforated cathode. And it means we can see some rays are coming, and some rays are coming from the side of the anode, and they are passing through these holes which were present in the perforated cathode. Understood, class, or not understood? Okay, and then strike the gauge, since they are passing through from these holes, and they are able to pass through these holes, and then they are striking here. Since they are striking here, and that's why we can see the fluorescence. Which side? At the back of what? At the back of cathode, right? It means there are some positively charged particles which are coming from which side? Which are coming from anode, and they are moving towards cathode, and then they are passing through these holes and they are striking at the glass wall of the discharge tube at the back of the cathode, and then this proves that they are carrying a positively charged particle, because they are attracting towards which side to which side? From positive side to negative side, and we know that opposite charges always attract, right? So since these rays are coming from the side of the anode, therefore they are called anode rays. So what should be the name? Anode rays. Why these are known as anode rays? Because they are coming from anode, and anode is a positive electrode. right? So therefore they should be called as a anode rays, since they are passing through the holes. Since the passing through the holes, so what we can see here, what we can see here, what we can see here, since they're passing from these holes, we can see that they are known as canal rays, because they pass through the holes or canals in the cathode. Further, their deflection in an electric field shows that they carry positively charged. Now, how we can prove that they are carrying positively charged? If you remember, in the last class, I have shown you, if you keep any electrical field in the path of these rays, so you will observe that these rays will attract toward the, these rays will show the deflection toward the negative part of that, negative plate of the electrical field, right? It means they will show deviation in the electrical field. And when you keep when you keep there any magnetic field in the path, they will also show deviation. It means we can say that anode rays will show deviation in the electrical field, as well as, tell me, as well as a magnetic field. Why they are showing? Because if you want to confirm that what kind of charges they are carrying, well, we need to keep something, oppositely charged in their path, right? So when any electrical field was applied through that, so it was found that the rays which were coming from anode, they have started deviating toward the negative plate of the electrical field. This proves that they are carrying positively charged particles, and later on these particles were known as protons. Understood or not understood? Okay. Now one more thing I would like to highlight. So if I say ki how of origin of anode rays, we know that anode rays do not originate from the anode. We know that. Actually, they are not coming from the anode, but they have given them name anode rays. Why? Because it was appear to coming out from the anode. But actually, we know that the rays are not coming out from the anode. Something is there inside the discharge tube. Yes. What was there inside the discharge tube? What was there inside the? He has taken a gas at a very low pressure, right? So how much pressure we should apply? At a very low pressure, right? So anode rays do not originate from the anode. They are produced in the spaces between the anode and cathode. This is the space between anode and cathode. So actually they are coming from anode and moving towards the cathode. So we have given they have given them name anode rays, but actually we know that they are not originating from the anode. It means something is there in the between anode and cathode, so the rays were originating from there. So it is believed that the high electrical energy, how much volt? 10,000 volt. You know that how much volt was applied? 10,000 volt. So it is believed that the high electrical energy supplied between the electrode splits the molecule, right? They splits the molecule of the gas present in the, suppose H2 is there. Suppose hydrogen gas was taken inside that. So when you apply high voltage to that, then obviously they will knock out the electron because of the very high electrical energy, and these electrons which are present inside the atoms will knocked out. It means what will be left behind? Only H plus ion will be left behind, because hydrogen is having only one electron. And if you apply very high electrical energy on hydrogen gas molecule, so what is going to happen? Because of the high electrical energy, electrons will knocked out, right? So electrons present in these atoms further absorb the electrical energy and are knocked out, and the electron thus knocked out travel towards the anode. Obviously they will travel. You can see the electron which are knocked out are traveling towards anode. You can see two direction. You can see there is a one arrow and there is another arrow. Can you see that? So you can see the electron which were knocked out, they will start traveling towards the anode, right? And forms a part of cathode rays. So we can see the cathode rays are also there, and the remaining part of the atom becomes a positively charged. We can see H plus ions. Okay, it becomes H plus ions, and then what is going to happen? the remaining part of the atom becomes a positively charged particle, and these positively charged particles travel in the form of stream towards the cathode. And this stream is going to be, you can see the pink color stream this side, and the black color stream is going towards the anode, and this pink color stream is going towards, and they are passing through these holes. It means these are carrying positively charged particles, and these black rays are carrying negatively charged particle. That's why their direction is which side? Anode side, and their direction is towards cathode, right? Their direction is towards cathode. Okay, so the remaining part of the atom becomes a positively charged particle, and these positively charged particles travel in the form of stream towards the cathode. Because it is negatively charged particle, charged electrode, so obviously they will attract towards it, and then this stream of the rays are known as anode rays. They constitute the anode rays. How many of you have understood this? Yes, Sanya understood, beta. Have you understood how anode rays were generated? How anode rays were generated? Can you tell me? I will answer each and everything. I don't want to deviate the discussion. I just want to ask whether you have understood the discovery of anode rays or canal rays or not. Understood? Yes, very good. Now, I would like to show you something. If I keep something on their path, can you see they are traveling in the straight path? Right? Can you see they are traveling in the straight path? That's why they are going to strike to this. They are going to strike to glass wall. Since they are traveling in the straight path, so what we can say, they will strike at this side. Okay, now how we can prove that they are traveling in the straight path? Okay, so how we can prove that they are traveling in the straight path? We will keep something opaque object in their path. If you keep something opaque in their path, what is going to happen? We can see what they are going to cast a shadow. If you remember in the last class also we have done, if you keep something on the path, what is going to happen? If you keep something on the path, suppose if I keep anything, suppose I have kept this fan in the path. When these rays are going to strike, if I kept one opaque fan in the path, obviously we can see here the shadow of this object. So this proves that they are traveling in the straight path, right? Why? Because this can be shown by the fact, if any object is placed in their path, right, a shadow is produced at the back. We can see the shadow is produced here. So we can see shadow can be produced here. Understood or not understood? Okay, so however their speed is much less than that of cathode rays. If you remember, cathode rays electron speed was very high. Cathode rays speeds were very high because they were constituting negatively charged particle known as electrons, and their speed is comparatively less because they are constituting positively charged particles known as protons, right? So they travel in the straight path. How we can prove that? Now they may ask you how you can prove that the anode rays are traveling in the straight path. So if you keep any opaque object in the path, right, so a shadow is produced at the back. Understood, class? Now they are made up of particles. Okay, so how we can prove that they are made up of particles? How we can prove that they are made up of particles? So what we can do that, if you keep any fan in their path, you can see when they strike, when these rays are going to strike, this fan is going to rotate. The fan which is made up of mica, if you kept on their path, this fan is going to rotate, right? So this proves that they are made up of material particles. They are made up of material particles, right? So this can be shown by the fact, if a light pedal wheel which is made up of mica, because we can take only light pedal, we can't keep anything heavy. We can't expect that the proton rays are going to rotate a very big heavy fan. No. So if we keep any light pedal wheel mounted on an axle, this should be mounted on an axle, right? and is placed in the path, it begins to rotate. It begins to rotate. This proves that these rays are made up of material particle, right? And now, if I ask you how you can prove they carry a positive charge, for studying the deflection in the electrical field, a cathode with a single small circular hole was used so that a fine beam of anode rays is obtained which travel straight, produce a fluorescent spot at a point. To observe measurable deflection, a strong electrical field of about 2000 volt was applied between two plates P1 P2, right? So that we can see what? We can see that they are showing deflection, right? It was observed that anode rays are deflected towards the negative plate of electrical field, right? Suppose if we keep something here, if any electrical field is kept here, right, as a positive plate and a negative plate, what is going to happen? Obviously, instead of going straight, they will start diverting towards which side? Toward the positive plate. They will start diverting towards the positive plate. So you can see the deviation of the anode rays towards the positive plate of the electrical field. This proves that they are carrying positive charge. Understood? They carry positive charge. Understood or not understood? You can see the deflection. Let me remove this. Okay. So, how can you prove that? How can you prove that? If you keep any electrical field in their path, then obviously they are going to show the deviation towards the positive plate. Electrical field will always have a two plate, one positive plate, one negative plate, right? Positive plate will be connected to the positive terminal of the electrical source and negative plate will be connected to the negative terminal of the electrical source. And then when the anode rays will generate, so they will show anode rays are deflected towards the negative plate of the electrical field. This and that produces fluorescence, and this proves that they are carrying a positive charge, right? They are carrying positive charge. Thanks a lot. Nice, ma'am. Who is this person? Why they will now see? I'm talking about they are going to, they will see. There are two things, right? If one negative plate comes in between that, so see, you can see that there is a distance between anode and cathode. But if you keep something in between, obviously instead of going straight, they will go, they are getting this negative plate first now. So obviously, understood or not understood? So they are going to travel towards what? They are going to travel towards which side? They are going to travel toward the negative plate, right? So they will not go straight in that case. Obviously they will attract, but now since they are getting negative electrode in their path, negative plate in their path, and we have applied electrical field of 2000 volt in their path, obviously they will show the deviation, because you can see this cathode is little bit far from the electrical field. Suppose if I apply electrical field here, this is the negative plate and this is positive plate, right? Understood? So obviously they are going to show deflection towards first, because this is coming first. This electrical field is coming first. Understood or not understood? Okay. So now we can see the next. Now let's revise the properties of. We have understood how these can be, how anode rays can be produced in the discharge tube. So let's see. So properties of anode rays. Just now we have discussed the first property, right? Okay, they travel in a straight lines. They travel in the straight line. Just now we have proved, because if you keep any opaque object in their path, what is going to happen? They'll cast a shadow at the back of the cathode. And then second thing, they are made up of what? Material particle. Just now ma'am, actually you said in between that they will move towards positive plate. So okay, understood. maybe in the flow I must have said, but now you should know that, because we are discussing positive plate, positive negative plate like this, so maybe, but I mean to say they are going deflection towards the negative plate of that, because the rays are coming from which side, from anode to, they were going towards the cathode. It means they must be carrying positively charged particles, they must be carrying positively charged particles. Obviously they are going to show the deflection towards which side, obviously the negative plate of the electrical field. And even if you keep any magnetic field in the path, they will show the deviation towards the in the magnetic field also. So it will, they will show the deflection in the magnetic field as well as electrical field. And then they are made up of particle, just now we have discussed they are made up of material particle. How you can prove that? I had told you, if you keep something in their path, what is going to happen? If you keep any light wheel pedal in their path, what is going to happen? It is going to rotate, it is going to rotate. So why they are rotating? Because when the anode rays will strike on this light pedal wheel, they will start rotating. It means they must be carrying some material particles, and they, which has mass. And one more thing, they generate what? They are carrying positive charge also, we can prove with the help of electrical field. Just now we have discussed this, right? So they carry positive charge, and the mass of positively charged also depends on the nature of the gas. Okay, so the mass of the positively charged particle is also depends on the nature of the gas, because electrons are the has the negligible masses, but the protons are having masses which is equal to the mass of one hydrogen atom, that is 1u. So mass of the positively charged particle also depends upon the nature of the gas, because when you see hydrogen gas, mass is 1u only, but if you see the helium mass is 4u. So helium mass is 4u. So now, and then one more thing I would like to tell you. So when it was determined the charge upon mass ratio, like you, if you remember, sorry. So if you remember, if you remember the in the last class we have discussed the determination of the charge per mass ratio of the positively charged particle present in the anode rays, how it was judged, then by applying method similar to J.J. Thomson. If you remember Millikan's oil drop experiment, right? And Thomson, and that is by studying the extent of the deflection of the anode rays by applying electrical field and magnetic field of a definite strength. And then they have calculated charge upon mass ratio, that is you can see E upon M, right? Right? So, and it was found that the ratio E upon M, E upon means charge upon mass, right, is not constant. It is not, but in case of electron it was constant. But in case of proton it is not constant. It was found that the E upon M is not constant but depends upon the nature of the gas taken in the discharge tube. Yes, ma'am? Yes, ma'am. Web of Sachan is written. Okay. So, and then next very important thing, that mass of the positively charged particle, as I've said, the mass of positively charged particle constituting the anode rays is also found to be what? To depend upon the nature of the gas and the voltage applied, right? However, the charge is found to be a whole number, multiple of the charge present in the, so if I say relative charge, it may be 1 plus, plus 2, plus 3 units, depending upon the number of electron knocked out from the gaseous atom. If we have knocked out 1 electron, 1 plus charge can be seen. If we have knocked out 2 electron, to 2 plus charge can be seen, right? Like helium. If I take helium, if I say helium atom, so if in helium atom we know that 2 electrons are there. If you remove 2 electron, helium 2 plus charges can be seen, right? So it depends upon what? How many electrons we have knocked out by applying high voltage electric current. Okay, so now the question comes, if I want to define proton, so how we can define proton? Okay, so how we can define proton? So proton definition says that, so let me reduce the size so that definition can be seen easily. Yes. Now you can see proton is defined as a subatomic particle. You can see the proton is defined as that subatomic, or you can say the fundamental particle, because it is also a fundamental particle. Without proton, any atom cannot exist because it is constituting the mass of an atom, right? So a proton is defined as that subatomic, or you can say the fundamental particle, which carries 1 unit positive charge and has mass nearly equal to that of hydrogen atom. And that's why if we want to represent a proton, so how we can represent proton? 1p1 means superscript also 1, and it means the charge is 1 and the mass is 1u. Understood? So how proton can be shown? It can be shown like this. Understood or not understood? Okay, so it means the charge on the proton is 1 and the mass of this proton is 1u. It is represented by the symbol 1 1, 1 superscript, 1 subscript p, small p. In fact, a proton is nothing but an ionized hydrogen atom only, right? Because in class 10 you will study that electrons are proton donors. It means they are giving H plus ions. So if I say, in fact, what is proton? Proton is nothing but an ionized hydrogen atom. That is, it is obtained by the removal or the loss of only electron present in the hydrogen atom. In the hydrogen atom, since only one electron, one proton is there, it knocked out one electron from hydrogen atom, one proton will be left behind. So obviously we can say, what is proton? Proton is nothing but an ionized hydrogen atom. That is, it is obtained by the removal or loss of only electron which is present in the hydrogen atom. So to conclude that protons are constituting of all the atom, it is found. What was the conclusion after this experiment? It is found that in case of any other gases other than hydrogen atom, right? Other than hydrogen taken in the discharge tube, the mass of positively charged particle was found to be a whole number and multiple of the mass of proton. Suppose if I say mass of helium, so 4u, right? Understood? And then, which implies that all atoms contain whole number of proton. We can't say 1.5 or 2.5 atoms are present. So hence we can conclude that proton must be fundamental particle present in all the atoms, because all the atoms contain whole number of protons. For example, if I say sodium, sodium has how many proton and how many electrons? We know that atomic number of sodium is 11. It means 11 proton, and 11 is a whole number. We can't say that 11.5 protons. Yes or no? Understood? And what is the absolute mass? The relative mass of proton is to 1u. If you compare with the hydrogen atom, relative mass of hydrogen is 1u, proton is 1u. But what is the absolute mass of proton, which was calculated by E upon M ratio? So 1.67 into 10 to the power minus 27 kg. And what is the value of the charge? What is the absolute value of the charge on proton? So we can see it is 1.6. You can see electron and proton both are having equal value of charge. You have seen in case of electron, it was minus 1.6 into 10 to the power minus 19 coulomb. But nature of the charge was negative, because electron is negatively charged particle. And when you see proton also has the same numerical value of the charge, that is 1.60 into 10 to the power minus 19 coulomb. But the nature is positive. Understood? Understood, class? So nature is positive. Okay. So I hope everybody must have understood. Okay. Now I would like to tell you one more thing in that. What was the mass of electron? If you remember, if we need to compare, like we have compared the charges. So in the last class we have done, if I say mass of electron, so mass of electron is 9.1 into 10 to the power minus 31 kg. And just now we have seen its value of charge, that is minus 1.6 into 10 to the power minus 19 coulomb. And I told you the mass of proton is equal to mass of neutron. If neutron is having relative mass 1u, and the proton will also have neutron mass is 1u, proton mass is also 1u. It means both are having equal mass. So approximately same masses. Understood, class? In the next class, we will be studying the all the models, right? Since we have completed the discovery of, then I will introduce you the discovery of neutron also in the next class, and then we'll study Thomson model of an atom, and then Rutherford model of atom, and later on Bohr's atomic model, right? And there are so many topics which are important in this chapter. So I hope everybody has understood this. Do you have any doubt in that? Yes, class? Any doubt in that? Who has discovered this? Everybody must have understood now. Who has discovered this? Who has discovered protons? Can we revise? You have to give me, beta, you have to give me answer. Have you understood this discovery of proton? Have you understood discovery of proton? And you have any doubt? And now we also know the properties of anode rays, that they travel in the straight line, they carry positively charged particles like this. Understood or not understood? Right? And they show the deviation in the electrical field and magnetic field, right? And what is the value of the charge on that? We have understood. What is the value of the mass, absolute mass value is what? So we have understood everything. Okay, so next class is very important class. I will show you the working kind of model of Thomson, right? And then we will understand Rutherford experiment, right? That is also very, very important. Rutherford model of atom with the help of discovery of nucleus by understanding the Rutherford scattering experiment. Okay, so best of luck. I am going to end my class. Thank you very much. God bless you all. Please revise this. Okay, thank you.